Welcome, dear learners, to this video. Our topic for today in physics is linear motion. So the word linear motion, what it simply means, we can break down the word linear. Linear refers to straight lines. Okay, linear refers to straight line. Okay, straight line. And motion simply means movement. So what we are basically looking at under linear motion is the movement of objects in a straight line. Okay, movement of objects in a straight line. Okay, so a straight line can be written like this. Okay, this is a straight line. It can also be written like this. This is also a straight line. Okay, it can also be written like this, or these are straight lines. Okay, so if a board is moving in straight lines like this, okay, we're saying that it's under what? Linear motion. Okay, it is under linear motion. Okay, so just by looking at this, okay, this we call it, this is an increasing motion. Okay, this one, it's a decreasing motion. And when it's flat like this, usually this one we call it constant motion. So increasing motion simply means that it's positive, in the positive direction. This is in the negative direction. Now here, constant meaning there's no change. Okay, there is absolutely no change. Okay, there is absolutely no change. So now, even before we dive into the linear motion, we need to look at two basic quantities. Okay, and that is distance distance and displacement. Okay, distance and displacement. Now, distance and displacement, distance is simply we can define distance as the total length taken between 2 points. Okay, total length taken. So if you have point A here and point B there, okay, so if you take down this length, okay, you take down this length, okay, so total length taken. Okay, so that's the definition for distance. Total length taken between 2 points. Okay, total length taken between 2 points. Okay, same thing. If we can define displacement here, it is simply the change of position. Okay, the change of position of a point in a particular direction. Okay, you can say displacement is the change of position of a point. Okay, so in a particular direction. Okay, in a particular direction. Okay, in a particular direction. So I'll give you a scenario just to make this point more clear. So distance and displacement. So let us say you're at point A here, and you want to go to point B, which is here. Okay. So as you're standing here at point A, you want to reach point B. So let's say you have a mountain here. Okay. And here you've got a tree. Okay. You have a tree. So now let's say you want to take down this path. So the road will take you up like this, come back, you pass the tree, and you reach point B. Okay. So this is what we call the total path. Okay, the total path taken. Okay, the total path taken. Okay, and here you are now at point B. So when we measure this length, okay, from here up to here, this is what we call distance. Okay, this is what we call what? Distance in red. Okay, one I've shown in red is the distance. Okay, that's the distance. But for displacement, we're simply looking at the change in position. So you are at this position A, and you want to go at position B. So you simply change position like that. Okay. So this one, it's displacement. Okay. The one in red is what? That is the distance. Okay. So distance, that's the whole difference. Okay. When you look at it like that. And now, again, what you need to know is that for distance, it is what we call a scalar quantity. Displacement, it's a vector quantity. Okay. Now, what does these two words mean? Scalar quantity will mean this is a physical quantity that only has, okay, only has magnitude. The other word for magnitude, we're simply talking about size. So scalar quantity only has magnitude, okay? But vector quantity, this one, has both what? It has got magnitude, okay? It has magnitude as well as direction, okay? It has both magnitude and what? And direction, okay? It has both magnitude and direction, okay? Both magnitude and direction. So when we look at distance and displacement, they are SI units, both of them. It's meters. They are both measured in what? In meters. Meters is denoted by a small letter m. Okay, these are the SI units for both. Okay, these are the SI units for both. Okay, and the the formula. Okay, for distance. Okay, so before we even look at the formula, let's dive into what we are calling linear motion. Okay, then we're going to understand something. Okay, so now when we talk about linear motion, okay, linear motion, when we talk about linear motion, what are we trying to talk about? So linear motion was simply saying that for all motions, okay, we got motions in straight line. Okay, motions in straight line, motions in straight lines, okay, motions in straight lines. And when we look at motions in straight line, we are going to look at two important things here. Okay, number one is the speed, okay, velocity, and acceleration. And these three are linked together, okay, together with the distance and the displacement. Okay, they are linked together. Okay, so again here the difference here, speed is a scalar quantity. Okay, it's a scalar quantity. A scalar quantity, by now we know that it is a quantity that has only what? Magnitude. Velocity is a vector quantity, meaning it has both magnitude and direction. Okay, it has both magnitude and direction. Okay, both magnitude and direction. Okay, but since we're looking at straight lines, okay, straight lines, okay, so if something is moving in a straight line like this, okay, this thing is moving at this point to this point in a straight line. Okay, here there is no distance, there is no difference, there is no difference between distance and displacement. Okay, why? Because these motions are in a straight line. So when we talk about linear motion, there will be really no difference when we talk about speed and velocity. They will be actually the same, because we are looking at linear motion. Okay, and that is the reason why when you look at speed, you look at the SI units. SI units for speed, okay, SI units for speed are simply meters per second. Okay, the same thing, velocity, SI units are meters per what? Per second. Okay, and we'll be using them interchangeably, okay, because we're looking at linear motion. So under linear motion, okay, speed and velocity are basically the same thing. Okay, speed and velocity are basically what? The same thing. Okay, under linear motion. And also distance and displacement, there is no difference, okay, between the distance and the displacement. Okay, so now let's look at, now we begin looking at speed. That's the first thing we're going to look at, speed. Okay, so speed, so we know what speed is. We use this word in our everyday life. Okay, can you increase the speed? Okay, when someone is driving, can you increase the speed? Or can you reduce the speed? Okay, so speed by definition, okay, it is the rate of change, okay, rate of change of distance, okay, rate of change of distance moved with time. Okay, rate of change of distance moved with time. So look at this, let me tell you a secret. Whenever you hear a definition starting rate of change, okay, just know that when you want to write the formula for speed, because of this statement rate of, meaning this formula will be divided with time here. Okay, with time here. So we're saying it's the rate of what? Change of what? Change of distance. Okay, so the distance comes here. So distance is denoted by x. Okay, distance is denoted by x. Okay, or other people, they'll say speed is equal to distance over time. Okay, but let's stick to x to represent distance. So x represents distance, time, okay, t represents time. So time in seconds, distance in what? In meters, okay? And then S represents speed. The SI units meter per second, okay? So speed is the rate of change of distance moved with the time, and that's the formula, okay? That is the formula, okay? That's the formula. Let's look at now we look at velocity. So velocity by definition, velocity is defined as, look at again, it starts with the rate of change of displacement, okay, with time, okay, rate of change of displacement with what? With time. And now the formula, velocity is simply equal to what? Okay, so rate of change, so over time, okay, rate of change, okay, so rate of change of displacement, rate of change of what? Of displacement. So displacement here again, we're going to denote it by xi, rate of change, okay? So I'm going to add this, okay? I'm going to add this, okay? A triangle. So this simply means change of displacement. So here again, I can add the triangle to simply mean change of distance, okay? Change of distance over time, change of displacement over what? The time, okay? Over the time, okay? So that is speed and what? And velocity. That is speed and velocity, okay? That is speed and what? Velocity, okay? So now that we've learned about speed and velocity, so velocity, V is equal to velocity SI units meters per second, okay? X is equal to displacement SI unit meters per second, T is equal to time, SI unit seconds, okay? SI unit what? Seconds, okay? SI units are seconds, okay? So this is what we call velocity, okay? So we looked at velocity and we've also looked at speed, okay? And we've looked at the difference between the two. We looked at the difference between the two, okay? So let's look at an example, okay? Let's look at an example, okay? So this example, got an example. Okay, example A. So now this example says that a car travels a distance of, okay, a car travels a distance of 540 kilometer, okay, from Lusaka to Katete. Okay, a car travels a distance of 540 kilometers from Lusaka to Katete in 10 hours, okay, in 10 hours, okay, and we're told find the speed. Find the speed. Okay, we find the speed. So we know speed is equal to, okay, rate of change of distance over what? Over time. So from the question we've been given the distance is 540 kilometers and the hours, the time, it's 10. So we're going to say x, we've been told it's 540 km, which are kilometers. Time, it's 10 hours. Now remember, okay, before we even work out here, we said the SI units, okay, for distance should be meters. The SI unit for time should be seconds. But in this case, we've been given kilometers and what? Hours. So we need to change. We need to change the kilometers into what? We need to change the kilometers into meters. And we need to change that 10 hours into what? Into seconds. Okay, we need to change these things. Okay, so we're going to change them here. Okay, so we have 540 kilometers. We need to change it to what? To meters. We need to change this to meters. So we know 1 kilometer is equal to 1000 meters. Okay, 1 kilometer is equal to 1000 meters. Okay, what about 540 kilometers will be equal to how many meters? Okay, this is how you convert. So x times 1, that is x, is equal to 540 times 1000. This will give you this. Okay, so we've gotten what? 540,000 meters. Okay, 540,000 what? Meters. Okay, that's not the only thing we're converting. So we've converted the 540 kilometers into meters. Okay, then the other thing we're supposed to convert, okay, we're told we have 10 hours. Okay, time is equal to 10 hours. Okay, so we need to convert 10 hours into seconds. So we know that 1 hour, okay, we know that 1 hour is simply equal to, okay, 3,600 seconds. Okay, just know that in 1 hour there are 3,600 seconds. What about 10 hours? X. So 1 times x, you get x is equal, here you're going to have 36,000 seconds. Okay, so now we know that 10 hours will give us 36,000 seconds, and 540 kilometers will give us 540,000 meters. So we've done our conversion. Okay, we've converted these. Okay, we've converted these. So now we know this is the same as 540,000 meters. Okay, 540,000, and we know 10 hours is the same as 36,000 seconds, because we have to deal in meters and seconds. We have to deal in meters and seconds. Okay, so now we can answer this question. Our distance, it is what? 540,000 meters over our time, it is 36,000 seconds. Then we calculate. So these zeros can go, these zeros can go. Then now we simply divide 540 over 36, and this will give us 15 meters per second, and this is the speed. Okay, this is the speed. Okay, so you might be given kilometers or hours. You need to change these into what? Meters and into seconds. Okay, you need to change them from meters into seconds. Okay, so that's just an example on speed. Okay, example on speed. So let's look at acceleration. Acceleration, we'll look at two things under acceleration. We're going to look at two things. Okay, acceleration. Now acceleration, look at the definition again. Rate of change. Okay, rate of change of velocity. Rate of change of velocity with time. Okay, so acceleration is a vector. So by now we know what vectors are. They have both what? Direction and magnitude. Okay, that's what vectors are. So rate of change. So acceleration is denoted by a small letter a. Okay, this denotes acceleration. So I'm going to say a is equal to, okay, a is equal to change of velocity with what? With time. Okay, change of velocity with time. Okay, so now let's look at what is this change of velocity that we're talking about. So change of velocity simply means that it's a change from what to what time. So when you say something has changed, meaning it's moving from something going to somewhere. Okay, so this means this change of velocity is the same as v minus what? U. Okay, where v, this v is the final velocity. Okay, and the u is the initial. So when I say initial velocity, I'll use the letter u. Okay, so v is the final velocity and the u is the initial velocity. So in other words, the formula for acceleration is simply equal to final velocity minus initial velocity over time. Okay, over the what? The time. Okay, over the time. Now the SI units. Okay, SI units for acceleration, very important. SI units for acceleration, it is meter per second squared. Meter per second squared. Those are the SI units for acceleration. Okay, meters per second squared. Okay, let's look at an example. Let's look at an example. So this example says that, so example A says that a car starting from rest increases its velocity uniformly to 15 meters per second. Okay, in 5 seconds. Okay, calculate its acceleration. That's the question, eh? So a car starting from rest. So I'll give you a hint here, or something that you should always follow. Okay, so the keywords to note from the question. Always read the question and understand first. So the keywords to note is that this car is starting from rest. This is a very important point. It is starting from rest. Increases its velocity to what? 15 meters per second. In how many seconds? In 5 seconds. Okay, so let's write our formula. We know acceleration is equals to final velocity minus initial velocity over time. So now, this word starting from rest, this simply means that our u is equal to 0. Whenever you see that the car started from rest, just know that u is equal to 0. Okay, so meaning u is equal to 0. U is what? It is the initial velocity. Okay, so this means that our initial velocity is equal to 0. So whenever a car starts from rest, just know that your initial velocity is 0. Okay, your initial velocity is what? 0. So it increases to velocity. So now this is the final velocity. So final velocity is what? 15 meters per second. Okay, and the time is simply 5 seconds. Okay, 5 seconds. Let us now find what is a, which is our acceleration. Okay, what is a, which is our acceleration. We're going to come down. So final velocity is 15 meters per second minus initial velocity is simply what? 0 over time, that is 5 seconds. Okay, this will be 15 over 5. So 15 into 5, we get 3. Okay, so acceleration is 3. What are the SI units for acceleration? Meters per second what? Squared. Okay, this is the units for acceleration, for acceleration. Okay, so now that is the example. So what have we looked at? We looked at acceleration. Okay, we looked at speed. Okay, we looked at velocity. Okay, so now before we end the video, let's look at what we call deceleration. Okay, let's look at what we call deceleration. The deceleration, it's just the same, it's under the same principle as acceleration. Okay, so deceleration, just the opposite of acceleration. So deceleration is also called as retardation. SI units, the same SI units as what? As acceleration, which are meter per second squared. Okay, so now deceleration, this is when a car is slowing down. Okay, is when an object is doing what? Slowing down. Okay, when it's slowing down. Okay, slowing down. Whenever a car slows down, it's in what? Deceleration. Okay, it's in deceleration. So deceleration here, it will always be a negative. Okay, to always be a negative, and we'll see that soon when we do an example. So it will always be negative. Okay? Deceleration will always be negative. Okay, that's the same formula. Okay, so deceleration, we write the same formula for acceleration. Okay, v minus u over t. Okay, but our acceleration will always be what? A negative. Right? Always be negative. So let's look at this example. Okay, example 2. Okay, in this example we're told, okay, this example we're told that if a car slows down from the car slows down from 72 kilometers per hour, and stops in 10 seconds. Calculate its deceleration. Calculate its what? Deceleration. So I told if a car slows down. So the keywords in this question: slows down. So we know we're dealing with deceleration. And it's slowing down. So the other keyword is stops. So mark those keywords I've given you: slows down and stops. So when we say it stops, this tells you that your final velocity is 0. When you just see that the car stopped, just know that the final velocity is what? Is 0. The final velocity is 0. So meaning what we have here will be your initial velocity, which is 72 kilometers per hour. Now we need to convert this 72 kilometers per hour. We need to convert the 72 kilometers per hour. I'm not going to waste time telling you, no, do this. I'll just tell you a simple way of changing kilometers per hour into meters per second. A simple way how we can change kilometers per hour into meters per second. So that's what we want. We want to change this. That's what we want. So I'll show you this simple way that you can be using. So we've been given, we have what? That is 72 kilometer per hour. Now we need to change this to meters per second, which are the SI units. So to change them to meters per second, always divide by 3.6. Always divide by 3.6. Always divide by 3.6. So when you divide 72 kilometers per hour divided by 3.6, we simply get 20 meters per second. So always divide by 3.6 to change kilometer per hour into what? Meters per second. So 72 kilometer per hour is the same as 20 meters per second. 20 meters per second. So in other words, our initial velocity, we've converted it to 20 meters per second. And what is the time? The time we're told it's 10 seconds. 10 seconds. So this means that acceleration will be equal to final velocity minus initial velocity over t. What is our initial velocity? Remember, when you see that the car stopped, just know that your final velocity is what? Is 0. So that is 0 minus our initial velocity, which is what? 20, over the time, which is 10. 0 minus 20, you get negative 20 over 10. Over 10. Then you can cancel here and there. So 1 into negative 2, that is negative 2 meters per second squared. And this is our deceleration. Have you seen that our answer is a negative? Our answer is what? A negative. So that's all we are going to look at in this video. I hope you've been able to understand something. Please, if you have any question, leave it on the comment section. If you want to contact me, look at my bio on the YouTube channel. There is my number. Okay, so if you are maybe new to the channel, please subscribe, like, share and comment.